Hey folks, let's do the geometry mock exam together. So problem number 1 says triangle WPK is congruent to triangle PWF, and it says to use the congruent statement to mark the diagram. There is your show the work hint. So when we use the triangle congruent statement, we know that the first two are congruent to the first two. So I'm going to come over to the diagram and find WP and PW. Well, they are the same side, so that's this side right here. And we're going to take the second and third, and they're congruent to the second and third. So PK is right here. I'm going to give that 2 tick marks, and WF is this one, so I'm going to give that 2 tick marks. And then from there, we know the first and the third is congruent to the first and the third. So WK is this guy, and that is congruent to this right here. I already have 2 angles marked, and by the third angles theorem, I know that these must also be congruent. And it wants to know what's congruent to PK. Well, this is PK. It has 2 tick marks. It must be congruent to WF that also has 2 tick marks. Number 2, find the measure of angle E in isosceles triangle EGP. So it's telling us that this is an isosceles triangle, and I see the congruent tick marks here that say that those 2 sides are congruent to each other. And I know that in an isosceles triangle, the congruent legs are across from the congruent angle. So that angle right there is congruent to this angle right here, which means that if I have this angle labeled 8x, that this angle is also 8x. And by the triangle congruence, no, not by that, by the third angle, not by that either, holy guacamole, the triangle sum theorem, I know that 8x plus 84 is equal to 180. And from here, I'm going to say 16x plus 84 equals 180. I'm going to subtract 84 from both sides. 16x is equal to 180 minus 84. I feel like it's 96, but rather than being a hero, I'm just going to go to my calculator and let it do it. 96, and I'm not interested in 16x. I want to know what x is. So back to my calculator. Divided by 16 is equal to 6. And again, I'm not actually interested in what x is. I want to know what the measure of angle E is. So the measure of angle E, well, since these 2 angles are congruent, we said that angle E was 8x, and we just said that x was 6. So that guy is 48 degrees. Make certain that you're reading these statements, because on this one, x wasn't there, but in future problems, the value of x will be there, and you'll be responsible for knowing what the right answer is. This one says, what's the length of segment QR? And QR is this guy right here. And I look at the diagram and I see that this line is perpendicular to the segment, and this line is bisecting the segment, which means this is a perpendicular bisector. And we learned that in a perpendicular bisector, any point on the perpendicular bisector is equidistant from the endpoints of the segment, which means that this segment and this segment are congruent to one another. So that means in order to solve this, I'm going to say 9n minus 12 is equal to 4n plus 18. I'm going to subtract 4n from both sides. That's going to give me 5n minus 12 is equal to 18. I have minus 12, so I'm going to add 12 to both sides. 30. N is equal to 6. 6 is one of my distractors, but I need to find the length of QR. QR is equal to 4 times n, which we just said was 6, plus 18. 24 plus 18, not relying on my head right now. 24 plus 18, double check that I typed that in right. 42 is the final answer for that one. ED is the midsegment of triangle QRP. ED, this is the midsegment of the triangle. What is the value of x? So we're just figuring out what is the value of x. Well, we learned that if you took the length of the midsegment and doubled it, if you multiplied it by 2, then it was the same length as that side. So I'm going to take this to midsegment equals side, and into it I'm going to plug in this midsegment ED, and I'm going to be certain to use parentheses, so I double the whole side and not just part of it. It's equal to the side that it's parallel to, which is 5x minus 2. I'm going to go ahead and distribute 6x minus 20 is equal to 5x minus 2. I am going to subtract 5x from both sides. X minus 20 is equal to negative 2. I'm going to add 20 to both sides. X is equal to 18, and it wanted the value of x. There it is. Let's go. Number 5, in triangle ABC, the measure of angle A is 38, the measure of angle B is 65. Draw triangle ABC and use it to put the sides in order from shortest to longest. Okay, I have no idea what this triangle looks like, right? But right now, I don't even know if this is an acute triangle, an obtuse triangle, or a right triangle. So my first thing I'm going to do is say, I don't know what the measure of angle C is, but if I add that to the measure of angle A and the measure of angle B, those three would add up to 180, and that would tell me what angle C is. So I am going to go to my calculator and add this, 38 and 65. 38 plus 65 is equal to 103, and I'm going to have to subtract 103 from 180, so I'm going to do 180 minus 103, double check my typing, so C is 77. So basically, just in case you don't like what I just did there, 103, and then we subtracted this. And that told me that the measure of angle C was 77 degrees. I'm not looking for notation for this. This was just rough work to figure out what that angle is. And basically, when I find that out, I go, okay, this is less than 90 degrees, this is less than 90 degrees, this is less than 90 degrees. All three angles are less than 90 degrees, which means that this is going to be an acute triangle. So I'm going to draw a triangle, and I'm not going to really try to make it look like anything. I'm not trying to make it look isosceles or equilateral or anything. I'm just, all three angles need to be acute. At this point, I'm going to label it, and 38 is my smallest angle. It looks like this is my smallest angle. So this is angle A, and this right here is 38 degrees. And then my next biggest angle looks like this guy over here. And so I'm going to call this B and label it 65 degrees. And then that means that this is my biggest angle coming in at 77. What we learned this semester was the smallest angle is across from the smallest side. So 38 degrees is my smallest angle, which means it is across from my smallest side. So side BC is my smallest side. So because we're going from shortest to longest, BC would be the first thing listed. And this does not have BC, the first thing listed. Part of that whole theorem is that if the shortest side is across from the smallest angle, then the biggest angle at 77 is across from the biggest side. So that means that side BA or AB is the biggest side. So I'm going to come back over and I'm going to expect to find that in this column. So I am looking at this one. BC is the smallest, AB is the biggest, and there we have it. AC by default has to be the middle side. And there we go. Use the Pythagorean theorem to find the missing length. Pro tip, anytime we've got a right triangle, we're going to start out by drawing that arrow from the angle to the side opposite and labeling it the hypotenuse. So if I'm using the Pythagorean theorem, I'm going to do the two sides that are not the hypotenuse. I'm going to square each of them together and add them together and set them equal to the hypotenuse squared. So 4 squared plus 7 squared, I'm going to take this directly to my calculator. I'm not looking for the same level of work on this as I would your a typical quiz or test where you're showing all your work, but you do need to do the start out and some steps along the way. The square root of x squared is x, and the square root of 65 is not 65. And it's not 8 either. The square root of 64 is 8. The square root of 65 is not 65. And the square root of 65 is truly the square root of 65. This would be simplest radical form. There's not a perfect square that goes into this. The answer for this is C. Find the value of x. Give your answer in simplest radical form. There's a couple of ways to approach this. Pro tip, there's my right angle, and that means that this side right here is my hypotenuse. I notice that these sides are congruent, which makes this an isosceles triangle. I know in an isosceles triangle my base angles are congruent, and if one of my angles is 90, then each one of these angles has got to be 45 degrees. This was something that we learned this semester. And if I have a 45, 45, 90 triangle, I can say that the hypotenuse is equal to the leg, either leg, since they're both the same, times the square root of 2. I've already labeled the hypotenuse 12. In that goes. If this is the hypotenuse, this has to be a leg. And we learned that we're not allowed to divide by a radical because we're not allowed to end up with radicals in the denominator. So I am just going to go ahead and multiply both sides by the square root of 2. Squeeze that in there because I like the radical last. We learned that the square root of 2 times the square root of 2 is 2. That's why we're doing it. What can I do to both sides to make that not a radical anymore? And that is going to leave us with 2x on the right-hand side and 12 radical 2 on the right-hand side. Trying to get x by itself, x is being multiplied by 2, so I'm going to divide both sides by 2. Now, this is perfectly legal. And at this point, those guys cancel out, and on the right-hand side, I'm left with x. Over on this side, I'm going to divide the stuff that's outside the radical. 12 divided by 2 is 6. My final answer is 6 rad 2. There you go. Find the value of x in the given hexagon. I don't know about you, I cannot remember what a hexagon is. So I'm going to start here and say 1 side, 2 sides, 3 sides, 4 sides, 5 sides, 6 sides. This is a 6-sided figure, and we learned that if we did n minus 2 times 180, where n was the number of sides, that told us what all these angles added up to. So I'm going to plug in this and go to my calculator. 6 minus 2 is 4. So 4 times 180 is equal to 720 degrees. Okay, so that means all of these angles add up to 720. I am going to start here and go around clockwise and stop at this one. So I'm going to say x plus 130 plus 130 plus, you got to know that this means 90 degrees, plus 90 plus 90 plus 160, 1, 2, 3, 4, 5, 6. If it has 6 sides, it has 6 angles, and all of that stuff adds up to 720. So at this point, I'm going to go to my calculator, and I'm going to add up all this stuff. So 130 plus 130 plus 90 plus 90 plus 160 is equal to 600. I'm sorry, I know it's painful to watch me use the calculator. And then I'm going to subtract 600 from both sides, and I'm not going to make you watch me do this in the calculator. That is 120. So this is 120 degrees. All we were doing was finding x. In this particular case, x represents an angle measurement, so that's why there's the degree symbol on that. Sometimes we put it angled, whatever. I'm not going to, the semester's done. I'm done teaching. All right, I'm not done teaching. I will always be here for you, but I don't want to lengthen this. Find the measure of angle DCE in the rhombus, where the measure of angle DCE is 11x plus 24 degrees, and the measure of angle DFE is blah, 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 blah. Okay, so let's start out with the measure of angle DCE. So here's D, we come down to C, and we go up to E. Well, it says that this is a rhombus, and that's that. And I know that in a rhombus, a square and a kite, the diagonals are perpendicular to one another. So in this problem where it's asking me what the measure of angle DCE is, see this? I don't care. See that? I don't care. The measure of angle DCE is 90 degrees. this problem was going to be way more complicated. Originally, I was going to have you figure out what that was, but I was like, that's going to take them 10 minutes. What I really want to know is, do they know that this is 90 degrees? You better know that it's 90 degrees. All right, let's move on to number 10. Use the markings on the diagram to classify the quadrilateral. And note it says that this is a 1-point problem. That's because there's not really any work to show. P.S. There's not a whole lot of work that you can show here. Throw me that right angle mark in there, and that'll be the work. Otherwise, you're going to be showing a lot of work, and you're going to get the wrong answer, but you'll still get a point for getting tripped up by all that extra information. I didn't mean for it to be evil. I meant for it to be nice, but some of you are not going to watch this video and end up doing a lot more work, and I apologize for that. Use the markings on the diagram to classify the quadrilateral. This is a 1-point problem. I'm not expecting to see any work. I'm going to have to mark up my diagram just so that I can communicate with you. The first thing I notice here is this right angle, and I go, it's a rectangle or a square, and that's the problem. I don't know. And I look down my choices, and I see rectangle, rectangle, rectangle. So for certain, this is a rectangle. And if it's a rectangle, it also has to be a parallelogram. I mean, that's just automatically. You can't have a rectangle that is not also a parallelogram, which means that this is already disqualified. So at this point, the difference between these two answers are, is it just a parallelogram and a rectangle, or is it also a square? So things that I know about a rectangle. I know that the diagonals bisect each other because that's true for all parallelograms. That's true here. Based on the way this diagram is marked, this diagonal is bisecting this diagonal. But since this side and this side are the same as this side and this side, that means that this blue diagonal and that pink diagonal, they're ultimately the same length, and that is true for a rectangle. So everything says rectangle so far, but nothing says square. Well, the definition of a rectangle is a parallelogram or quadrilateral with 4 right angles. The definition of a square is a quadrilateral with 4 right angles and 4 congruent sides. The sides are not marked congruent. Now, there are other things that it could tell me that could indicate that it's a square. Because the diagonals are perpendicular in a rhombus, and all squares are also rhombuses, and that's that family tree thing coming into play. If I knew that the diagonals were perpendicular, then I could say it's a square, but it doesn't say that. If I knew that the diagonals were bisecting the angles that it was going into, like if I knew that this angle right there was congruent to this angle right here, but not only do they not look congruent, who cares what they look? It's not marked. None of that information is conveyed to me. So because there's nothing that is telling me it's a square, I need to say that this is a parallelogram and a rectangle. In fact, it is. Find the value of x. That's all we're looking for in this, the value of x in parallelogram ABCD. Well, in a parallelogram, we know some stuff. We know that opposite angles are congruent. This is an acute angle, that's an acute angle, this one appears to be obtuse. And we know that consecutive angles are supplementary. So if I add these two angles together, their total is 180. So that's what I'm going to do. I'm going to say 4x plus 20 plus 9x minus 35 is equal to 180. 4x and 9x is 13x. 20 minus 35 is negative 15. I'm going to add 15 to both sides. 195. I'm going to take this to my calculator. 195 divided by 13 is equal to 15. And I just need to verify that I'm just doing x. There it is. Find the value of x for trapezoid WXYZ. Now, the definition of a trapezoid is a quadrilateral with exactly one pair of parallel sides. And I look at this side right here, and I go, if I extended it, eventually it would cross with this side. So those two are not parallel to one another. So that must mean that this side right here is parallel to that side right there. And if this side and this side are parallel, that means that this acute angle and that obtuse angle must be supplementary. So I'm going to say, since they're supplementary, I'm going to do 4x plus 30 plus 118 is 180. And I'm going to combine like terms. Plus 148 is equal to 180 minus 148 from both sides. 4x is equal to 180 minus 148 is equal to 32. If you don't know what 40 or 32 divided by 2 is, use your calculator. No shame in that. X is 8. We are only finding the value of x. The answer for that one is B. The triangles shown are similar. Use the similarity statement to solve for x. We're just figuring out what x is. Okay, so in my estimation, this is the problem that is going to trip you up the most, just because you're going to be probably a little bit stubborn. And we learned that the ratio of corresponding sides for two similar triangles was they're all the same. So the ratio of the first two and the first two, because these are corresponding sides. That's what this similarity statement says. It says, I'm lining this up so that you can make a nice, neat distinction about what sides are corresponding. So if I said the length of side HG divided by the length of side MN is equal to the length of these two corresponding parts, so the length of side GF divided by the length of side ML, that ratio is also going to be equal to the first and third over the first and third, NL. And I go over to my diagram, and one of the things that I notice is this side HF is not marked with any kind of length, and this side NL is also not marked with any kind of length. So ultimately, I am not using that information at all. So I am just going to use this bit of information, and I'm going to fill it in with stuff that I know. So according to the diagram, HG is 26, and NM is 13. According to the diagram, GF is the side marked 2x minus 4, and the side marked ML is 12. Now, if you recognize that this is a fraction that can be reduced, go on with your bad self, because I suspect that a vast majority of people will not. I'm not going to do it. The way we're going to do a problem like this is cross multiply. I'm going to take the denominator for my left fraction, and I'm going to multiply it by the numerator on my right fraction, and I am going to put that binomial expression into a set of parentheses. And I'm going to take the denominator of my right fraction and multiply it by the numerator of my left fraction. All right, and at this point, I'm going to go ahead and distribute. I can do this. This is 26x. 13 times negative 4 is negative 52. I had a lot of cards growing up. There are 13 cards in a suit and 4 suits and 52 cards in a deck. So that's why I know that one off the top of my head. But 12 times 26, don't know. 312. 312. I need to add 52 to both sides. 26x is equal to 364. I am going to go to my calculator because I need to do 26 divided by 26 on both sides. So 364 divided by 26 is equal to 14. 14. We're only solving for x. 14 is one of my options. The answer is A. If you happen to notice that this was reducible, you could say that 26 over 13 reduces to 2 over 1. So you could do 2 over 1 times 2x minus 4 over 12, and your math would have been a little bit simpler, but if you didn't recognize it, you're still going to end up with the same answer. A student who is 5 foot 3 inches tall measures her shadow and the shadow cast by a water tower shaped like a golf ball. What is the height of the tower? Express your answer in feet and inches. The problem on the exam will be done just like this. The student will be expressed in feet and inches. All the shadows will be given to you in inches only. You're going to going to convert everything to inches to get you started, and then your answer needs to be expressed in feet and inches. Okay, so if she is 5'3", 5 times 12 is 60, plus 3, that means the student is 63 inches tall. Sorry, those weird noises I'm making, I'm trying not to cough because I have allergies. Okay, so she is 63 inches, and we're trying to figure out the height of the water tower. We know that when we set up these proportions, we have to do the corresponding sides. So the girl corresponds to the tower. So the girl over the tower is going to be equal to the girl's shadow over the tower's shadow. Do you have to write this? No, this is just me expressing so that you know why I'm doing it this way. So I'm going to do 63 over x, 63 inches over x. Again, you don't need to write that inches. This is me so that I can communicate with you. Over the girl's shadow is 60 inches, and the tower's shadow is 480 inches. Again, if you recognize that this can be reduced, your math is a little bit easier. I'm not going to do it just because I think most people will not recognize it. Okay, all of these units are in inches, which means that when we find the height of the tower, it will be measured in inches, and then from there we're going to have to convert. So I'm going to do the cross multiplication, left denominator by right numerator. That's going to give me 60x. Right denominator times left numerator, so 480 over 63. So 480 times 63 is equal to 30,240. 30,240. This is 60x. I need to divide both sides by 60. That's going to give me divided by 60 equals 504. So 504, and this is in inches. In order to figure out how many feet and inches 504 is, I'm going to say 504 divided by 12. So I'm going to take this. I'm not going to just hit divided by. It'll import the answer for you. Divided by 12 is 42. Awesome. So this is now 42 feet. So there's my answer. If this gave you something else, so parallel universe, I am going to just, if you needed to convert, say, 617, if I do an odd number that I know for certain isn't divisible by 12. So if something is 617 inches, that's going to equal how many feet and how many inches. So just so that you know how to do this in case it comes up on the exam. So you would take 612 and you would 617 and you would divide by 12. So in this case we would do 617 divided by 12, and that would give us, this calculator is so helpful, 617 divided by 12, and there's two ways that you can get to a decimal on this calculator. If you hit the decimal and then hit enter, that's going to give you a decimal answer. So we're going to have 51.5147. So 51.5, I forgot, 4167. All right, 4167. Well, this means that this right here is the number of feet. So this is 51 feet. So on my calculator, I'm going to subtract out the feet part, and then that's going to give me this, 4167. But I'm not going to clear and type this in because there's more digits that the calculator isn't showing me. Watch this. If I hit minus 51, see how it has all these digits here? That's why I'm doing it this way. So that's telling me this right here is the part of a foot. So I'm going to take that and I'm going to multiply it by 12. So times 12, and watch, this is going to magically be a nice pretty number. So you're going to take this and multiply it by 12, and that gives us, what did it say, 5 inches? That's what it said, 5 inches. So in the event that you don't have a full foot situation going on here, that's how you would do it to get the feet in inches. All right, look, this is one of the distractors, 504. Make certain that you know what it is that you're finding. Okay, let's keep moving. Find the sine of angle C. Now, I think this one tripped people up when you were working in class, SOHCAHTOA is what we're using for this. We're dealing with sine, so we know that the sine is equal to, according to our acronym, opposite over hypotenuse. All it's asking for is, what's the answer to this? It is not saying what's the measure of angle C. It's literally saying when you plug in the opposite and divide it by the hypotenuse, what's the answer going to be? So according to the problem, we're working with angle C, and across from angle C is the opposite, labeled 4. And the hypotenuse is always across from the right angle, so this is the hypotenuse. So literally, we're just going to our calculators and doing 4 divided by 5. Well, 4 divided by 5 is 0.8. In fact, I'm not going to do it. You can do it if you want to, but there it is. All right. This one says find the length of JK. So when we are doing a problem where we know a side and an angle, or maybe we know 2 sides and we're trying to find an angle of a right triangle, then we're going to use trig. So first step is I'm going to look at the triangle from this perspective. So here I am considering the triangle while I'm standing here. And it wants to know the length of JK. JK is this side right here, and that side is adjacent to the angle that I know. And again, the hypotenuse is across from the right angle. So there's my hypotenuse. And when I do trig, I'm figuring out these things, and then I'm looking at these first letters, A and H. Well, on the last slide, we wrote CA, which is the cosine of an angle is equal to the adjacent side over the hypotenuse. So let's fill this in. The cosine of 29 degrees is equal to the adjacent. I don't know the adjacent. That's what I'm looking for, so I'm going to call it x, over the hypotenuse, which according to the diagram is 4. Whenever we have a variable in a fraction, we're going to multiply both sides by the denominator. So I'm going to multiply this side by 4, and I'm going to multiply this side by 4. The whole reason I do that is those guys cancel out, and I'm left with x is equal to 4 cosine 29. Now is when I'm going to pick up my calculator, and I'm going to verify I'm in degrees. If your calculator does not appear to be in degrees, call me over. I'll help you with that. And we're going to do 4. I'm going to find cosine, enter, 29, enter, and that gives me 3.498. And I'm rounded to the 2 degrees here, and I have a 1, a 2, a 3. So I'm pretty certain it's this one, but 49. Okay, that 8 would cause the 49 to round up to 50. So the length of JK is 3.50. And why did I even bother? Like, as soon as I saw that 3, why didn't I just come over here and circle? Because if I was wrong and maybe I tripped something up, then that would give me an indication that there was something happening. But it does round to exactly what I'm offered, so I feel confident in my answer. Find the area of a parallelogram. The area of a parallelogram is the base times the height. You don't need to write a whole lot for these problems. That'll do it. So 5.2 times 2.7, and that tells me 1404. There it is. It has the right units, miles squared. Find the area of the triangle. The area of a triangle is 1/2 the base. Now the base is just this part of the actual triangle, so 2.9, and the height is weird because in this diagram, the height and the base are always meeting at a 90-degree angle, and if they don't happen to meet inside the triangle, that's okay. This will work out just the same, so we're going to do this is our height. So 4.4. That's all you have to write for this one. Let's go to our calculator. When I type it in, I'm going to make this 0.5 because that's just easier, times 2.9 times 4.4. Oops, I typoed and did put the point in there, and that would make my decimal off. Double check my typing. Oh, I forgot the decimal in there too, so I'm going to go back and I'm going to insert that decimal right there. There we go, and I'm going to hit enter. 6.38 is one of my answers, so C, and moving on. For all calculations, use the pi button on your calculator, find the area of the circle. Now be careful because there's going to be one area and one circumference problem. This 12 miles is hovered right by the center. That 12 miles is the diameter. When finding the area of a circle, you need the radius, which is half the diameter, so the radius is 6. The area of a circle is pi r squared. Into my calculator, I'm going to type pi times 6 squared, and that gives me 113.097, which would round to 113.10, and there it is, B. Number 20, find the circumference of the circle. The circumference is 2 pi r, or the circumference is pi times d. This is hovered right there near the center, which means that this is referring to a diameter. So we can do pi times 6.4. To my calculator I go. Pi times 6.4 is equal to 20.11. 20.11. If your natural inclination was to divide that by 2 and do 3.2, you would end up with the exact same answer, because you're going to turn around and double that. But I don't know. I think this is going to appear on your formula sheet, so you can use either one of those, whatever makes you comfortable. All right, this one, just for clarity, the shaded is the rectangle part, and this is the part that's not supposed to be shaded. It definitely is shaded. My apologies for that one. So the area of the shaded region is going to be the area of the rectangle minus the area of the circle. All right, the area of the rectangle, base times height, 90 times 42, and the area of the circle, it is a whole circle. This little piece right here is the radius, so r is equal to 21, so pi r squared, and I'm going to go straight to my calculator and just type all that in. So 90 times 42 minus pi times 21 squared. Did I type? Oh, I did not type in. Look at this weird thing that I have here. Oh, all right. So I'm going to, oh, what have I done? I'm going to hit enter and start fresh. Sorry, 90 times 42 minus pi, I don't know what I did, pi times 21 squared. Okay, double check my typing. I'm pleased with that. 2,394.56. 2,300, there it is, it's B. And I just want to show you something. The TI Inspires come pre-programmed to only show 6 digits, or six digits. And in this particular case, there's more numbers on the other side of this decimal point, but it automatically just, like if there were 3 digits to the left of the period or the decimal, it would show 3 digits on the right. But since there's 4, it shows you 2. If there were 5 digits, it would only show you 1, and it would round. But I want to show you that if you were working on like the 30x2, you would have 2,394.5576, and this 7 would cause that 5 to round to 0.56. I just want to make certain that you're going to end up with something a little bit different shown on your calculator, and it's just because of the way the TI Inspire is. So I don't want you to freak out when you type that into your calculator and got a slightly different answer. Find the volume of the cylinder. Area of the base times the height. Well, the area of the base is pi r squared times the height. Now, this right here is the diameter, so the radius must be 6 miles, and this is the height of the cylinder. So pi 6 squared times 16, off to our calculators. So pi times 6 squared times 16, double check my typing, and 1,809.56. And this is the same thing, like if I hit multiply by 1 and hit enter, it would show, it actually shows something very, very similar to this. So there's my right answer, 1809.56. Find the volume of the prism whose base is a triangle. So we learned that in a prism, the base could be any kind of polygon. It could be a triangle, it could be a square, it could be a rhombus, it could be a rectangle, it could be a trapezoid, it could be a pentagon, it could be literally any of the polygons that we learned about. Now, there are polygons that we didn't learn how to figure out the area of, so we got to stick to the stuff that we know. So, oh, and the height was always going to, the faces of the prism were always going to be parallelograms. So I look at this and I go, okay, the thing that is not a parallelogram is going to be my base. So in this prism, my base is this triangle. So I'm going to find the area of this triangle, and then I'm going to multiply it by the height of the prism. So this is the height of the prism. Now, in this triangle, this h, this is the height of the triangle, and that 6 is the same length as this 6, so this is also 6. And this, the fact that this is a 90-degree angle, this is also a 90-degree angle. So my area of a prism is the base times the height. So for this, my base is 1/2 times 6 times 8, and the height of the whole prism is 13. So this is what I'm taking to my calculator. I'm going to change that point, or that 2.5 to 0.5. So I'm going to say 0.5 times 6 times 8 times 13 is equal to 312. There we go. Volume is cubic, so my units are on. Find the value of x, so we're looking for x, if segment DE is tangent to circle F. So there's a reason why it's mentioning that this segment is tangent to. If a segment is tangent to a circle at the radius, we know that this angle right here is a 90-degree angle. We learned that the tangent to a circle is perpendicular to the radius. Okay, so if that's perpendicular, then that says that we can use the Pythagorean theorem. We can say that this side of this right triangle squared plus this side of the right triangle is equal to this side of the right triangle. Now, I want you to take a looky at this, because this x is referring to just this segment right there. So we're going to figure out what this whole segment is, what I've got marked in pink. For now, I'm going to call this C, like the hypotenuse of a right triangle is C. And we're going to do this just to figure out what this whole thing is. And then from there, I'll figure out X. We'll cross that bridge when we come to it. But for the first part, we're going to say 9.9 squared plus 16.8 squared is equal to C squared. My answer is given with decimals, so I'm going to do this, and I'm not going to worry about like simplifying radicals or anything. So 9.9 squared plus 19.5 squared is equal to, that's not what I was supposed to do. Oh, here's a fun trick on this calculator. If you arrow up twice and highlight this, you can hit enter, and now I can just backspace and edit what I want to do. So what I really wanted to say was 16.8. I don't necessarily know that this particular trick is saving you a whole lot of effort in this. So 9.9 squared plus 16.8 squared gives us 380.25. So C squared is equal to 380.25. All right, I need to figure out what C is. C is being squared, so I'm going to take the square root of both sides, and that's going to tell me that C is, I'm going to do Control square root, Control answer, hit enter, and that tells me 19.5. I must have looked over at this before. So random that that's what I did. Okay, so 19.5. So this whole length is 19.5, and I need to know this. Well, the good news is I recognize that this radius, that 9.9, is also what's happening right here. So 9.9 plus x gives me the length of this c value. So 9.9 plus x is equal to that c value, which is 19.5. From here, we're going to subtract 9.9 from both sides, and that will tell me that x is 9.6, and I'm going to cross my fingers and hope that that's on there. Yay! Okay, the equation of a circle is x minus h, quantity squared, plus y minus k, quantity squared, is equal to r squared, where the center is at h comma k, and the radius is r. Okay, so this and this are opposite signs. So once I figure out what my center is, I need to, in fact, I'm going to come over here right now and I'm going to do this. And I'm going to come to my diagram, and if I find that I need to change the sign, I'm just going to do that. But I don't know. Let's see. My center is right here, and my center is at 2 comma 2. So x minus positive 2, that's that. And y minus positive 2 is equal to r squared. So on the diagram, what's my radius? 1 humpy, 2 humpies, 3 humpies, 4, 5. So r is equal to 5. We don't care what r is, we care what r squared is, which means r squared is 25. Scan the list, it's one of these two guys. Minus, 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 2, 2. There we have it. The answer for this is B. All right, on to the extended response stuff. We've already done problems kind of like this. And so here we have a parallelogram, and we need to find the value of x, which is referring to the variable in those two angles. And then we also have to find y, which is labeling the length of this side. Okay, so earlier in the exam, we did talk about how in a parallelogram, consecutive sides are 180. If you forget, if you get tripped up, are they congruent or are they supplementary? Just look, this is obtuse and this is acute. An obtuse angle and acute angle cannot be congruent to one another. So the only other option then would be to say they are supplementary. So I'm going to conserve space. I'm going to start my work way over to the far left, and I'm going to say 4x plus 10 plus 14x plus 8. We said supplementary, which means they add to 180. 4x plus 14x is 18x. 10 plus 8 is 18. Equals, there's a whole lot of 1s and 8s in this, minus 18, minus 18. 18x is equal to, I don't know. I mean, I have a guess, but 162. 162. I'm going to divide both sides by 18. And I need to have 162 loaded in there, so I'm just going to hit divided by 18 is 9. Awesome. 9. All right, it wants to know what the measure of angle R is. Here's the measure of angle R. The measure of angle R is equal to 14 times x, which we just decided was 9, plus 8. Have no idea what that multiplication is. So I've got 9 loaded in there. I'm just going to hit by times 14 plus 8. 132. Excuse me, 134, right? 134. On the answer line, I will be certain to put a degree symbol because by gummit, it's May, and you know that the measure of an angle is shown in degrees. The measure of angle S is 4 times x, which is 9, plus 10. You can use the calculator if you want to. That's 36 plus 10, which means this is 46 degrees. And as a check, I'm going to add 134 and 46 just to make certain they add up to 180. 4 plus 6 is 10. Put down the 0, carry the 1. 1 plus 3 is 4 plus 4 is 8. So there we go. We did things right. We learned that in a parallelogram, opposite sides are congruent. So this side right here is congruent to that side right there, which means that negative 4 plus 4y is equal to 20. Let's move this negative 4 by adding 4 to both sides. 4y equals 24. Divide both sides by 4. Y is equal to 6. And that's all we have to do. It doesn't ask us anything else. I suppose as a check, I could say 4 times 6 is 24, and minus 4 is equal to 20, which is what it needed to be. So this is also correct. All right, number 2, find the volume of the composite figure. Boy, you've seen this composite figure so many times, you know exactly what to do. This is asking us for the volume of the cone and the volume of the cylinder. Now, when we worked on this in class, I talked about, like, just set it up and go to your calculator once. I'm not going to tell you to do that for this. Let's find the answer, write it there. Find this answer, write it there, and then we'll add those two numbers together. So let's see. The volume of the cone is 1/3 pi r squared. Well, this is the radius of the cone. So 12 squared times 8. So the volume is approximately equal to, off to the calculator we go. I'm going to do 1 divided by 3, and I'm going to hit enter. And on your 30x2s, it's going to make this 0.333333 repeating, and you're just going to hit times and then type everything else in. Times pi times 12 squared times 8 is equal to 1206.37. Now, rounding to the nearest hundredth, if you have the little calculator, the 30x2 or whatever, you're going to have to do the rounding. For mine, it's already rounding to the nearest 100th. So 1206.37, 1206.37, 1206.37. We're going to work on the volume of the cylinder. The volume of the cylinder is pi r squared times h. There's no 1/3 for this one. So we're going to do pi. The radius of the cylinder is 24 squared. The height is 16. So the volume of the cylinder, let's go to the calculator, and this is going to be pi times 24 squared times 16. I got problems in River City because, remember, I already talked about it only shows 6 decimal places. I'm just going to hit times 1 so that this is giving me the full round. So my answer for this is going to be 28,952.92. 28,952. 28,952 point, and I can't remember 92. Listen, if you are using a TI or Inspire on the exam and you get freaked out about this, call me over. I'll help you with this part. Or just, it'll be fine. At this point, I need to add these two numbers together, and I'm just going to do that manually. So I'm going to do 28,952.92, 1206.37. By the way, I'm going to write this up here before I forget, because I want to get all the points. And if you don't write it on the answer line, then I think that you don't know what the answer is, and you're just kind of avoiding it. 2 plus 7 is 9. 9 plus 3 is 12, so I'm going to put down the 2, carry the 1. 1 plus 2 is 3 plus 6 is 9. 5 plus 0 is 5. 9 plus 2 is 1. Write down the 1, carry. 1 plus 8 is 9. 9 plus 1 is 10. Put down the 0, carry the 1. So the final answer is 30,159.29. And I'm pretty certain on the exam we didn't choose such large numbers, so that whole rounding issue won't be an issue. All right, find the center and radius of the circle. So FYI, this plus this is equal to this. So these are going to be, you got to watch the signs. Whatever sign you have is going to be opposite. So what I mean by that is my center, I have -3. I'm going to take the opposite of -3. My center is happening at 3, comma. I have +2. I'm going to take the opposite of +2. So -2. So my center is happening at 3, comma, -2. My radius squared is 25. So r squared is 25, and the square root of r squared is going to tell us that r is equal to 5. So my radius is 5. So let's go put our center down at 3 comma negative 2. And this is the thing where you have to show me 5 points, the center, and then count up, count left, count right, count down. And give me nice big points so that I know where you are aiming to go, because I'm not actually expecting anybody to draw a perfect circle. Although I will say this, some of you are darn fine circle drawers freehand. And I am not a good circle drawer, and I am especially not a good circle drawer using my tablet. So this is going to be some kind of lumpy and squishy looking. Yikes, that is not a circle. That's like baby Stewie's head. But because I have the circles, or the the points plotted, you know exactly what I was aiming for. And that's the exam, folks. Good luck, and let me know if you have any questions.